Hello everyone, I am Anurag, and in this series of machine learning, today I will be talking about some introduction to machine learning. So let's begin. This is me. I am currently an undergraduate at the Department of Computer Science and Engineering at Government College of Engineering and Textile Technology, Shirampur. So this slide is about some history of machine learning. The foundation of machine learning started in between 18th and 19th century. In 1763, Thomas Bayes gave one of his work, an essay towards solving a problem in the doctrine of chances, which was published 2 years after his death. And this paper was actually seen as a foundation to machine learning. This was the work underlying Bayes' theorem, and as we know that numerous machine learning algorithms have been built on that. A few more developments in the field of machine learning was seen as in 1997 IBM developed their own computer program Deep Blue, which was successful in defeating the then former chess world champion Gary Kasparov. Then in 2006 the first machine learning competition was launched by Netflix. Then in 2010 Kaggle, that is actually a website for machine learning competitions, was launched. In 2011, IBM's Watson beats two human champions in Jeopardy. In 2016, Google's AlphaGo program beats professional Go human players. So, this was all like advancements in the fields of machine learning. Moving forward, so this is about human learning. So, what human learning actually is, like, what is learning? So it is actually the process of gaining information through observations. With more learning, tasks can be performed quite efficiently. Three types of human learning are there with us. Like the first one being learning under some expert guidance, in which we take like some expert in that field who will be teaching us that particular concept. And that is how we will be like integrating the concept inside us, like the expert will be feeding that particular concept inside us directly. The other is quite indirect, like in this method we will be learning some kind of knowledge that from that particular expert, and will try to build upon that particular knowledge a notion that we could integrate later on. Now, the third could be like learning by self, or we also call it as self learning. So, we do it ourselves after multiple attempts, some being unsuccessful. So, it was all okay. But what actually machine learning is? Like, what is machine learning? So, some more fundamental question would be, do machines really think, or do machines really learn? According to Tom Mitchell, who is a professor at Carnegie Mellon Institute, so according to him, a computer program is said to learn from experience E with respect to a class of task T and a performance measure P. If its performance at tasks in T as measured by P improves with experience E. Like this is quite a traditional definition that has been followed by everyone. So what it exactly means is a computer program would be said like it is learning from something if it is learning from some experience E. Like some experience has been given to him and it is learning from that particular experience with respect to some task, like it is taking that experience so that it could perform a task, like could be T. Now, that particular computer programs accuracy, like accuracy would be a technical term, but its performance, like how well it is been measured by a performance measure. Let's say it as P. So its performance P at, like its performance at tasks in T as measured by P, like the performance that it would be giving, like the well, how well it will be performing in those tasks as measured by that particular metric P. If this particular like its performance is increasing, then we could say that it is increasing by learning from that particular experience. So, coming to the answer of the question, that do machines really think? So, it is quite obvious that yes, machines think and they learn too. So, the next question that would be coming is, how do machines actually learn, or how do machines actually think? So, they learn in a sequel of three steps. So, the learning process in humans is like, it could be done in three types, but in machines they learn in a sequel of three steps. They follow this particular three steps so that they will be able to like grab those, mm, like grab those knowledge. So firstly it would be data input, like some data would be given into that particular machines, and based on that past data or information they would be making some future decisions. The second step is abstraction. So it is like developing a conceptual linkage between that input data and the output that is supposed to be given. The third step would be generalization, in which we try to tune that abstracted knowledge or tune that mapping function to be technical. So let's try to see this, like let's try to visualize this by taking an example. So let's take an example. A child is born, and he starts visualizing the world around him. He grows up, gets into the school, and started his journey of formal education. Now when he is in lower classes, he is required to memorize the contents and puke them on the answer sheet during exams. Now in the lower classes, the more he can memorize, the better his grade card would look. But once he enters the senior section, it's no longer the same game. Now he is expected to answer the questions that wasn't made to be memorized by the child. Now, here to make the grade card look great, he will have to focus more on concepts rather than memorization. Now, once he has grabbed the concept well, he would be able to train his mind in a general way, which would help him to answer all of the questions that weren't memorized by him. So, relying on input data would be okay to deal with smaller problems, but whenever the problem grows, we will have to rely on some model which would build on the training data. So, moving forward, this is about the types of machine learning. Basically, machine learning can be broadly classified into three types. The first one being supervised learning or predictive learning, the second being unsupervised learning or descriptive learning, and the third being reinforcement learning. So, supervised learning, what they actually do is they try to predict the classes of an unknown object based on prior class related information of similar objects. In unsupervised learning, they try to find patterns in some unknown objects, and in reinforcement learning, they learn to act on its own to achieve the goals. We will be seeing about this three from the next slide onwards. So let's move. So, firstly, it's about the supervised learning. So, on a single line, what supervised learning is would be Supervised learning is learning from past experience. Like, for example, suppose from our childhood, we could remember that if we were given some homework and we didn't produce that to our instructor, then we were scolded. So, from that particular past experience, we have trained our mind in such a way that if we are not doing the homework that we have been given, we will be scolded. So, based on that past experience, we will be developing a mindset that whenever we are getting some kind of task to be done, we will have to do that. So, based on training data, which we also call as features, machine build a predictive model that can be used on test data to assign a label for each records in test data. Now, again, this supervised learning could be of two types. The first one being classification. Now, since the training data has a label or category, like suppose we are giving some x value which would be called as features, and we will be taking out some y value which will be the output, or which is technically called as label or category somehow. So, since the training data has a label or category defined for each and every image, or each and every features, we could say it like that also, the machine will create a mapping for each new test data to be a similar category. Now, this is with classification, and further we know that there is another type which is called regression. Now, regression is like predicting a real valued variable. So, let's see a little bit more about what classification actually is. So, classification is actually a process of categorizing a given set of data into classes. It can be performed on both structural as well as unstructured data. The process starts with predicting the class of a given data point. The classes are often referred to as targets, level, or categories, like I mentioned in the previous slide. So, some of the typical classification problems would be image classification, prediction of cancer or prediction of some kind of disease, win lose prediction of games, recognition of handwriting, and all. Like, we have seen that in many of the World Cups and all, there is some probability graph showing around in the corner of the television. So that's basically built upon some machine learning algorithm. Like, they try to predict on which side the game is going, like that team A is winning or team B is winning. So that's it. That's our classification. The next is about regression. So it is a statistical method that is used for predictive analysis that makes prediction for continuous real or numeric variables such as sales, salary, age, product price, etc. So it is like some of the examples would be like stock price prediction, and then petrol price prediction and all those stuff. Linear regression algorithms show a linear relationship between a target variable y and one or more predictor variables. Now, why I'm saying this as one or more, I'll be telling it a little. So, using the statistical concepts of least square method. So, you can learn about this least squared method from Google and all. So, they are trying to show a linear relationship, or they are showing a linear relationship. So, since they are showing this linear relationship, so they are known as linear regression. So, the nomenclature behind linear regression is from this particular relationship of linearness that they are showing between the target variable and the predictor variable. So, if we are using only one predictor variable, so it would be called as simple linear regression. While if we are using more than one predictor variable, then it would be called as multiple linear regression. A typical simple linear regression is represented in the form y is equal to alpha plus beta x. Now, here y is the target variable, while this particular x is the predictor variable. Now, since here we have used only one predictor variable, so it could be called as a simple linear regression. So, this is about unsupervised learning. So, it is like the machine is given the knowledge to learn to group data. Like they will be getting this particular data, and based on some particular patterns in this training data, the machine will build a group that can be used on test data to align or assign a label for each record in this test data. Now, unsupervised learning are of two types. One of them is clustering, in which we try to form clusters or groups. Like some clubs are being made for that particular levels or that particular features to be specific. And whenever we get some new test value that are quite similar or like quite near to that particular clusters, we will be telling that this particular new data that we have got as a test value is inside that particular cluster. The second type is association analysis. So it's basically like identifies all sorts of association. So let me tell one example for association analysis. Whenever we buy some product on Amazon or Flipkart, we see that we get more recommendations of products to buy. So this is basically association analysis. Like inside their database, it has been stored that whenever a person is buying a product, let's say X, then this person most often buys another product Y. Like for example, suppose we are buying a laptop, so it's quite obvious that they will be buying one mouse or keyboard, like some accessories with that. So whenever you are buying some laptop from Amazon or Flipkart or any other like online marketplace, so they will be recommending you some particular mouse or some particular keyboard to buy. So this is basically unsupervised learning. This is basically association analysis, which is an unsupervised learning. So here comes the third type of machine learning, that is the reinforcement learning. So reinforcement learning is an area of machine learning concerned with how intelligent agents ought to take action in an environment to maximize the notion of cumulative reward. So let me take one example. So whenever a child is born, so he doesn't know how to walk, okay, but he can see his parents who are like walking around him or her. So he tries to ape them. He tries to ape them, and he does it in some way, like he sees his father walking or he sees his mother walking. So from that he tries to do that particular thing in the way he sees the others doing it. So from that, there might be some scenarios that he is like falling into some obstacle and all. In that scenario they won't be getting some reward, but whenever that particular child is walking on their own, their parents would be giving them some kind of reward, and from that, or like giving some kind of reward, or they could be like praised on that. So this would create some kind of reward mechanism inside them. They would get to know that whenever they are stumbling into some kind of obstacles, they won't be rewarded, but whenever they are walking on their own without crashing into some kind of obstacles, they are rewarded. So this is kind of the reward function that uh, is involved in reinforcement learning. So the purpose of reinforcement learning is for the agent to learn an optimal or nearly optimal policy that maximizes the reward function. So this is the reward function that I have mentioned in the example. So in that example, the reward function was getting loved by the parents or getting some kind of reward from the parents. So this was like this. So the purpose is to maximize the reward function or Another user provide reinforcement signal that accumulates from the immediate rewards. So this is quite technical, so leave it as of now. This is similar to the process that appear to occur in animal or human psychology. For example, biological brains are hardwired to interpret signals such as pain or hunger as negative reinforcements, and pleasure and food intake as positive reinforcements. One contemporary example is self-driven car. So let me give another example. Whenever we are feeding some kind of birds, so let's say we are having some parrot in a locality, or some kind of bird in a locality, or pigeons in a locality. So whenever we feed them, they tend to like show some kind of belief towards us, and they tend to come quite closer towards us. While if you are like shooing them away, so they tend to move away from you. Like what I am saying is, suppose you are having a bird in your locality and you feed it every day. So you will see that that particular bird will be coming near you quite often. Like they won't be fearing anymore to come closer to you. Like they know inside them that this particular guy is going to feed me something, or like this feeding is like signaling some kind of positive mechanism or positive feedback inside that particular bird. So this is a reward being given to that particular bird. Now whenever you are shooing it away, so it's a negative reward that has been given to that bird. So it knows that what is that positive reward and what is the negative reward. So he also, the bird behaves accordingly. So this reinforcement learning is all about this.